Let's go back over to your VPCs and click Create VPC up at the top. And we are going to go ahead and call this one Shared-VPC. For the IPv4 CIDR block, we're going to put 10.2.0.0/16. And just as before, we're not going to assign an IPv6 CIDR block, and we will leave the tenancy as default. Click the Yes Create button. Next up, we'll create a database subnet for our database instance. Let's go over to Subnets. Click the Create Subnet button. And under the name tag, we're going to put database. Make sure that it is in the shared VPC. And under availability zone, we're going to put this one in zone 1A. And the CIDR block we'll use is 10.2.2.0/24. Now remember that when we created our web pub subnet in the web VPC, we also placed that subnet into zone 1A. We want the database instance and the web server instance in the same zone. And the reason is that if you've got two interdependent systems that talk to each other, in this case a web server talking to a database server, they should ideally be in the same zone. Placing subnets in different zones encounters additional fees, generally about 1 cent per gigabyte. This is why you don't want to let Amazon pick the zone for you, because you may end up with instances in different zones talking to each other and eventually running up your AWS bill. Okay, go ahead and click Yes Create. Now we're going to create a new routing table that will associate with the database subnet. Let's go ahead and click Route Tables. And then click Create Route Table. And we are going to name this route table Shared. And of course, place this in the shared VPC. Now, why am I calling this thing shared? Why not call it database? Well, suppose later on I want to create another subnet for a different workload. Let's say it's for a bunch of file servers. I may still want to associate that new subnet with the same route table as the database subnet. The reason is I want to minimize the number of route tables that I have to manage. Let me show you what I'm talking about. Let's go ahead and click Yes Create to create this. Now go ahead and make sure the shared route table is highlighted and click on Subnet Associations and then click Edit. Now what you can do is you can associate multiple subnets with a single route table. And once again, this is for scalability. You don't have to have a separate route table for each subnet. Sometimes you do need a separate route table for different subnets, and we'll get into that later. But here we have only one subnet to associate to this route table. So let's go ahead and click the checkbox. We'll click Associate here and then click Save. Next, we're going to bring up our database server instance. Let's go up to Services, click on EC2, and then right there in about the middle of the page, go ahead and click Launch Instance. And we're going to take a slightly different approach this time because we don't want the database server to have a public IP address, just a private IP. So we're not going to create an ENI or security group beforehand. Go ahead and click on Community AMIs. And let's go ahead and search for the name AMI-1CB6B467. And that's the same image we used before. We'll go ahead and select this. T2.micro for the instance type is fine. Click Next. Now this instance is going to be in the shared VPC, so select that and then make sure the database subnet is selected, which it is because it's the only subnet in that VPC. Now scroll down to Network Interfaces, and under the primary IP we'll put 10.2.2.41 and then click Next. Stick with the default storage settings and click Next. And let's go ahead and add a name tag here. We're going to name this one DB1 and then click Next. Now for the security group, we're going to create a new security group. Let's go ahead and name this one database-SG. And we want to allow SSH from any IP in the 192.168.0.0/16 subnet and the 10.2.0.0/16 subnet, which again covers our on-premises networks and the shared VPC's CIDR respectively. Let's go ahead and add a description to that effect, internal SSH. Now, when all is said and done, we don't want to allow SSH access from the web pub subnet because if, say, the web server instance gets compromised, we don't want a hacker to be able to use it as a jump host to get SSH access to our DB1 server. So we're not allowing SSH access from the web VPC. Okay, let's go ahead and add another rule here, add rule, and we want to permit MySQL access to the database server from the web instance. So under type, let's look for MySQL/Aurora. That's TCP port 3306. And the source address is going to be 10.1.254.0/24. That's the web pub subnet. And then let's go ahead and add that to our description, web pub subnet. And then now let's add one more rule here. We're going to do all ICMP IPv4, and we're just going to allow this from anywhere and then click review and launch. Now, for some reason, AWS thinks our security group is open to the world, although it's not clear what that means exactly. It's probably because we're allowing ICMP, but that's okay. Let's go ahead and click launch. Go ahead and confirm that we want to use this key pair, and then click launch instances. Once the instance launches, click the instance identifier, and here's our database instance. Now, the www1 instance needs to be able to reach it, but it's in a different VPC. So to get connectivity between these two VPCs, we need to set up a VPC peering connection. And that's what we're going to do in the next module.